Hello everybody, hope all of you are doing well. Myself Shubham. Currently I am doing my masters in chemistry from IIT Dhanbad, and we are going to discuss about the aromaticity. Now first of all, what is aromaticity? Aromaticity is a property of an organic molecule which makes the molecule more stable, right? Look, here are two molecules here. This is 6 carbon compound and this is also 6 carbon compound. There are 3 pi bonds and there are 3 pi bonds. So, but this molecule is more stable, right? This molecule is more stable. Why? Because this molecule is aromatic. Now, we have to know which are the properties which makes a molecule aromatic. And the criteria is the molecules must have to be planar. The molecules must have to be planar. Secondly, the molecules have to be cyclic. It should have complete pi conjugation. And fourthly, it should maintain 4n plus 2 pi electron. This is Hooke's law. Okay. Now look at this compound. This is benzene. This is planar. Why this molecule is planar? Because all of the atoms here are sp2 hybridized, right? And sp2 hybridized atoms are planar. That's why this molecule is planar. Cyclic. Undoubtedly, this is a cyclic molecule. Complete pi conjugation. Now, if the pi bonds can relocate here, here, and here, that means we can get this. Look, all of the pi bonds can relocate throughout the molecule, right? That's why complete pi conjugation is here, and 4n plus 2 pi electrons. Look how many pi bonds are there. There are 1, 2 and 3 pi bonds. 3 pi bonds means 6 electrons, and we can write 6 in such a way: 4 into 1 plus 2 equal to 6 pi electron. That means this molecule, that means benzene, is maintained Hooke's law, right? So benzene is maintained all of these properties. That's why benzene is aromatic. Okay. Now go for the another example. This is a carbocation, right? This molecule is planar. Why this molecule is planar? Because this is sp2 hybridized carbon, this is sp2 hybridized carbon, and here is a carbocation. Carbocation is sp2 hybridized. That means this molecule is planar. Cyclic. Undoubtedly, this is cyclic molecule. Complete pi conjugation. Complete pi conjugation here. This pi bond can relocate here, so we get this pi bond can relocate here, so we get right. That means this pi bond can relocate all over the molecule, right? That means complete pi conjugation is here. 4n plus 2. Look how many pi electrons are there. There are 1 pi bond. That means 2 pi electrons. And we can write 2 in such a way, that means 4 into 0 plus 2 equals to 2 pi electron, right? So this carbocation is maintain all of these properties, all of these criteria, and that's why this carbocation is an aromatic species. However, this is the smallest aromatic species. Okay. Now go for the another example. Okay, this molecule is planar, this molecule is cyclic, complete pi conjugation. Complete pi conjugation, we can say that the pi bonds are located in such a way one after another. Means here is a pi bond, right? This is single bond, double bond, 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 single bond. That means one after another pi bond. That means complete pi conjugation, right? And 4n plus 2 electron. 1, 2, 3, 4, 5. 5 pi bonds. That means 10 electron. 10 electron means 4 into 2 plus 2. That means 10 pi electron, right? So that's why this molecule is aromatic. Because this molecule is maintained all of the criteria. Here is a note, important note. When you count the pi electrons, always count the peripheral electrons. Always count the peripheral electrons. Never ever count in electron from the middle. Okay? Always count the peripheral electron. Okay? Okay. Now we will discuss about anti-aromatic. Anti-aromatic compound. The molecules, the criteria, first criteria, the molecule must have to be planar. Okay? The molecules must have to be cyclic. Here also complete pi conjugation they should have, but they don't maintain Hooke's law. They maintain 4n pi electron. Okay? Molecule must have to be planar. This molecule must have to be cyclic. This their complete pi conjugation, and there should be 4n pi electrons. Take an example. Right? This. Okay? This molecule is planar because all of the molecules is sp2 hybridized. This cyclic, undoubtedly this is cyclic molecule. Complete pi conjugation, this pi bond can go here, this pi bond won't go here, and we can get okay, and 4n pi electrons. 1, 2, 2 pi bonds, that means 4 electrons, and 4 electrons means 4 into 1, that means 4 pi electron, right? So this molecule is anti-aromatic. Go for the another example. This molecule is planar. This molecule is cyclic, complete pi conjugation. Why? Because these pi bonds can relocate throughout the molecule, throughout the carbon ion. So this complete pi conjugation, and we have to calculate the peripheral electron, right? So here is one pi bond, that means 2 electrons and one negative charge. One negative charge means 2 electrons. That means 4 electrons, and that means 4n pi. So this species is also a anti-aromatic species. Okay. Now we have to go for non-aromatic. Okay, non-aromatic. For the non-aromatic molecules, the molecule must have to be, first of all, the molecules first have to be cyclic. The molecule first have to be cyclic. The molecule may or may not be planar. Okay, may or may not be planar. The molecules may complete, there should be complete pi conjugation, or there should not be complete pi conjugation. They have or they have not. It totally depends. 4n, there should be 4n or 4n plus 2 or something else. Okay. If that means, if this criteria is not maintained except the cyclic, then this molecule will turn into non-aromatic. Take an example. Look at this molecule. You can say that this molecule is aromatic. Why? Because this is planar, this is cyclic, there are 1, 2, 3, 4, 5 pi bonds, that means 10 pi electrons, that means 4n plus 2, where n equals to 2, that means that should be aromatic. But this is not an aromatic compound. This is non-aromatic compound. Why this is non-aromatic? Because it seems look like a planar molecule, but actually this molecule is not planar. Why this molecule is not planar? Because there is a hydrogen here and there is a hydrogen here. Right? These two hydrogen repel each other. These two hydrogen repel each other. That's why, due to this repulsive force, the molecule is still longer, no more planar. Okay, lost its planarity. And planarity is the one most important criteria for the aromaticity. Due to this molecule is not aromatic. Okay, this is non-aromatic. Why this is non-aromatic? Because this molecule is non-planar. Okay, so if we can make a try to convert this non-aromatic molecule to aromatic molecule, then what should we have to do? We should have to remove the two hydrogens, right? If we can remove the two hydrogens, then so that there will be no repulsive force, right? And the molecule should be planar. So if we can remove the hydrogen, this molecule will be aromatic. Okay. Now remove this hydrogen with this bridge. Okay. There we can put a CH2 here, so there will be no hydrogen will be. Okay. So this is an aromatic species. Clear? Okay. And if we go for the energy order, right? If we go for the energy order, then aromaticity, the compounds which are aromatic, they are more stable than non-aromatic. then anti-aromatic. That means anti-aromatic compounds are most unstable. Okay, aromatic compounds are most stable, then non-aromatic, then anti-aromatic. Okay, there is one more compound, one more classification actually, that is quasi-aromatic. That is quasi-aromatic. What is that one? What is that one? Look, this type of compounds. You can say, no, this molecule is not aromatic, but everybody wants stability. So these molecules also try to be aromatic. How can it possible? This is carbon and this is oxygen. Which one is more electronegative? Oxygen. So oxygen can pull up the electron, pi bond, and convert here. Okay. So now look at this system. Okay, this is aromatic. This type of compounds, so that's why this type of compounds are called quasi-aromatic. Okay, thank you.